Hi friends, in this video we will discuss about compounded annual growth rate. And before we discuss about compounded annual growth rate, that is CAGR, we will see what is absolute return. Assuming that we have this list containing 5 figures: 10,000, 12,000, 13,000, 14,000, 20,000. So basically what we are assuming over here is 10,000 is becoming 20,000 after 4 years. Okay, here when we are calculating absolute return, the year doesn't matter. So 10,000 is becoming 20,000 over a period of time. That is fine. So how we will derive absolute return? See, current value, that is final value, purchase value, that is initial value, divided by initial value, that is 10,000, multiplied by 100. So let us plug in these figures into this formula and we get this 100. This is 100%. There is 100% growth. 10,000 becoming 20,000 means it is 100% growth. This is how we can get absolute return. We can also calculate for, say, after completion of third year, 14,000, right? 10,000 is becoming 14,000. So what we will do, let us copy this entire thing and write here and change the value. So we'll write here 14,000 minus 10,000 divided by 10,000. And then what will happen? It increase at the rate of 40%, right? So 10,000 became 14,000. That is, it increased by 40%. So that we can calculate for this, we can calculate for this as well. The figures are very simple. Without calculating, we can tell what is going to be the result. So this is increased by 30% and this is increased by 20%. This is all about absolute returns. Let us discuss about CAGR now. What is the formula of CAGR? CAGR's formula is final value divided by starting value raised to the power of 1 by n, and n being the number of years minus 1. We will manually calculate and then we will use this in a function. Now, let us have these numbers. They denote years. We will create a data frame using this list and this list. So let us create this data frame. Our data frame looks like this, right? 10,000, 12,000, 13,000, 14,000, 20,000. After 0 year, after 1 year, after 2 years, after 3 years, after 4 years, what will be our CAGR, right? If 10,000 is becoming 12,000, what is going to be compounded annual growth rate? We will calculate. Okay, so the function has been written here, but we will first manually calculate. Look, 12,000 is become 10,000 is becoming 12,000. So what it says? Final value divided by initial value. So 12,000 divided by 10,000. And then what is that? Raised to the power 1 by n. So what we are saying? Raised to the power 1 by 1. Why we are writing 1? Because we are calculating for this 12,000. This is our final value. And how many years have elapsed? Just one. Hence, we are writing 1 by 1. See, the numerator over here is constant. Only denominator is going to change. And denominator is nothing but the number of years that have elapsed. So only 1 year has elapsed and minus 1 we are writing. So likewise, 13,000 is 10,000 is becoming 13,000 after 2 years. So we written 13,000 divided by 10,000 raised to the power 1 by 2. Why 2? Now it is after 2 years, hence by 2. And then next, 10,000 is becoming 14,000 after 3 years. 10,000 is becoming 20,000 after 4 years. We have written here manually, right? So we are going to get these. See, here the rate is going to be 20%. Average growth rate is going to be 20% for this line. And for this, after 2 years, this 10,000 is becoming 13,000 at the rate of average rate of 14.01%. After 3 years, 10,000 is become 14,000. Hence, the percentage being 11.86. 10,000 is becoming 20,000 after 4 years, the percentage being 18.92. We have already calculated like this. Okay. Now, for this, we have already written a function. There is no need to write like this. We have only 4 or 5 figures, so we have done it manually. But if the number of figures are more, then we will have to use function. Hence, we have written this function. Okay. So what we will do is we will invoke this function, and this is our list comprehension. We are taking amount from this data frame and also year. And then what we are doing, through each and every iteration, we are going to calculate CAGR for all the lines. First, final value comes. Final value means first 10,000 will come. N is what? 0. And if we have a condition, if N is 0, the value should be 0. So let us talk about the second value. Suppose final value is 12,000, n being 1. So what we'll do? We will pass final value, there is 12,000 to this function, 10,000 to this function, n being 1. And then this formula has been plugged into this function. And what it is going to do? Exactly this operation. See, this it is going to do. And it will give us 20% in return. Correct? Likewise, next, it will take final value 13,000, n will be 2, and starting value is constant, right? See, everywhere 10,000, 10,000, 10,000, 10,000 is constant. Hence, we have taken this variable as a constant value, and we are invoking this. Now, once we invoke this, all these values will get stored in a new column called CAGR, and it will be plugged into this data frame. Just see here. Let us see the data frame. The data frame is ready, right? So we already calculated manually. The same thing has happened here. See, first 20%, after first year, after second year, 14%, after third year, 11.86%, and after fourth year, 18.92%. The calculation has already been done. Look, we are storing CAGR in decimalized form. We can also say here, we could have written multiplied by 100, then it will give us 19.99 rather than giving 0.1999. Okay, the choice is ours. If we are not storing 19.99, we will directly multiply. If we are storing 19.99, then we will always, whenever we are using this, we will say divided by 100. So there is no need to multiply it by 100. So we will directly multiply by this decimalized number. Okay. So this is already there. We have calculated. Now let us deep dive into CAGR and try to understand what exactly it is showing. See, this note has been written and it is highlighting this point very clearly. And what is that? A major drawback of the CAGR is that it smooths out the growth rate and thus hides the volatility of the actual growth in the amount of capital. What does it mean? Look, if we look at this 20,000, the journey has been from 10,000 to 20,000 and the journey has taken 4 years. And it is giving us an impression that it has increased by 18.92%, right? But that is not the case. See, the calculation is such that this particular formula, it has given us 18.92%. But look at this data frame. First year, it increased by 20%. Second year, 10,000 became 13,000. The rate has been 14%. But the key over here is average rate, right? And then when 10,000 has become 14,000, the average rate is 11%. And when 10,000 become 20,000, is average is 18.92. But if it is average is 18.92, let us calculate this. We will calculate 18.92% right from here to here. So what is happening after 1 year, what is happening after 2 years, and what is happening after 3 years, and what is happening after 4 years, if the rate is considered like this. So let us run this and just see. Look, on an average, the principal amount grew at the rate of 18.92% over 4 years. And how it is happening? 10,000 is becoming 11,892. Second year is become 14,142. Third year it is 16,817. And after 4 years it is becoming 20,000. So had this been the rate, this would have been the journey of this 10,000. But that is not the actual case here. Look, after 1 year, the rate of growth has been 20%. After 2 years, the average rate has been 14%. After 3 years, the average rate has been 11.86%. After 4 years, it is 18.92%. So what is going on over here? Here, when we are told that in 4 years, the average rate has been 18.92. We would assume that every year it was 18.92. That is not the case. There will be a lot of volatility, and this is what it is. Let us discuss it further. Assuming that somebody says that at this point in time here, somebody says that the growth has been 20%. Growth has been 20%. Looking at this growth, assuming that this is an investment, we will invest some amount looking at this 20%. But next year, what is the growth? The growth is going to be very less, right? It is dropping. See, from here to here, it is 14% average. But from here to here, what is going to be the percentage? Let us calculate that. That will be very interesting. 13,000, 12,000, right? How we will calculate? How you can take the growth? Then we will say 1 divided by 1, because from here to here only 1 year has elapsed. So what is our formula? 1 divided by n. N denotes year. So only 1 year has elapsed. So we will write only 1 by 1 and then minus 1. Okay. the growth has been only 8 8%, right? We can also remove that. We can see this is 8%. We are writing minus only to eliminate this one. Okay. And if you want to see like this, we can just multiply by 100 and it will give you 8.33% has been the good growth from this year to this year. And what we looked at? We looked at 20% in 1 year and we thought that it will grow by 20% next year also, but it has grown only 8.33. Correct? Now, let us take another example. Let us make this empty cell here. Assuming that at this point in time, the person who is taking care of this investment, maybe you can say the owner of management of this investment says that, look, in the last 3 years, the average growth rate has been 11.86, right? This is what it is. And we find that 11.86 growth rate to be not attractive and we would not invest any money. And what is going to happen? Had we invested over here, take 14,000, it is becoming 20,000. And then what is going to be our growth for that 1 year? So make it 14,000 initial amount and this became 20,000. Had we invested 14,000 over here, what would have been our growth rate? 42%. This is very attractive. But this gave us an impression that, okay, average growth rate in the last 3 years has been 11.86. We thought it not to be attractive and we did not invest. But the next year it grew by 42%. See, this is what is completely hidden by CAGR. CAGR tells us what has been the growth from one point to another point and it completely ignores what has happened in between. Hence, whenever we look at CAGR, we have to be mindful of the fact that the average could be misleading, like over here. Okay, it has not grown by 18.9% every year. It is just very, very volatile. It is going up 20%, then 14%, then 11%, right? And if you only compare from 13,000 to 14,000, it is going to be very, very less. It is not going to be 40% next year, right? It will just come down drastically. Let us see that. 14,000 from 13,000 to 14,000. So 14,000 and this is 13,000. Only 1 year, right? So we are not going to change anything. 7.69%. And look here, this is 14%, 11%. Something is hidden over here, right? So these are the things we have to explore when we are looking at CAGR. It is not misleading. This is how the calculation is done. And we have to deep dive and discover certain facts which are hidden, right? So this is how, if the growth is going to be 18.92, 10,000 will travel like this in 4 years. 10,000, 11,000, 892, then 14,000, 60,000, and then it is becoming 20,000. Correct? It is traveling like this. But this is not what we are doing in CAGR. We only take 2 points. What is our initial point, initial money, and what is our final money? And then we try to take the growth rate, right? And if we are going to consider After 3 years, what is going to happen? After 3 years, the journey, how 10,000 is become 14,000. See, these rates are fine. These are very bumpy, right? We want to see if this is the rate, how it is growing. Then let us run this. So we are taking 11.86%, right? And the number of years, what? 3. Let us run this and just see. 10,000 will become 11,000, then will become 12,000, and then it is becoming 14,000. But we are calculating CAGR. We are plugging in this divided by this, and then 1 divided by number of year, that is 3. And then we are calculating. And that is how we are arriving at CAGR. Now, see, we talked about CAGR. Now let us talk about compound interest only. How we can calculate that? See, for compound interest only, what we can do is we will take the initial amount, and then this formula we will use and arrive at yearly compounded interest, only interest component, what it is going to be. So let us see that. This is the function we have written, right? Let us invoke this and run this. And what is this? Look, to arrive at CAGR, we use initial amount and the final amount. So final amount divided by initial amount raised to the power 1 divided by n. It gave us these figures. Having arrived at these figures, we can always arrive at what is our compounded interest. So here let us write, let us not invoke this, let us run this, right? Run this, and let me comment this, and we will run this again, all over again. See, what is this? Compounded, yearly compounded interest we are storing. If 10,000 is becoming 12,000, what is our compounded interest? 2,000. And we are calculating using this formula. Right, it is very much visible. We can say 12,000 minus 10,000, this is 2,000, that is fine. But we are using this percentage to calculate this. So what is that? We are writing principal 10,000 multiplied by 1 plus what is the rate? We can write 20 divided by 100, or we can write in decimalized form. So we can straight away write 0.2 and then raised to the power what? Here at this point in time it is n means year, only one, right? It will not make any difference, but still we can write. So it has become 12,000. And what is the yearly compound interest? 2,000, right? So we are, when we write like this, we are getting 12,000. We can always say, if we are only interested to see the interest amount, let me not write here, I will write here. Okay. If we are only interested to see the interest amount, then we will say minus 10,000. Then what we are getting? We are getting interest component only. And that is precisely what it is doing. Starting value multiplied by 1 plus CAGR raised to the power n, that is year, and then minus starting value. Again, this value has been written so that we get only compounded interest, not clubbed with the principal amount. If we want principal amount as well, then what we can do is we will comment this and we will uncomment this. Now what is happening? Just see. Now this 2000 will be 12,000 because we are not subtracting starting value after getting whatever it is giving us. So see, 10,000, 12,000, 13,000, 14,000, 20,000. So what we have done, we use these figures to derive this. Having derived this, we are deriving what is our principal plus interest. That is going to be same, right? So just it was a reverse calculation, nothing else. So what we will do is in the next video, we have considered this formula. And every time when we are calculating our compound interest, we are only calculating once, that is yearly. It is assumed that we are calculating compound interest only once. Compound interest can be calculated twice, that is yearly or half yearly. It can be calculated 4 times in a year, that is quarterly. We can also calculate monthly, that is 12 times. We can also calculate our compound interest daily, that is maybe 365 days or 366 days. So we will look into that in the upcoming video. Thanks for watching, and I will see you in the next video.